Okay, looks like we're recording. We're on. We're ready to rock and roll. I'm joined today here with Rong Chen. Rong, it's a pleasure to have you. How are you doing?
Doing great. How are you?
I'm great, thanks. And it looks like you're calling from a great backdrop there. It's stunning.
Yeah, thank you.
So, the title of today's podcast is Data Ownership and the Future of the Internet. So, from my perspective, I think you recently did a great interview with Ela Nation, and you looked into kind of Elastos, the Web3 project, which you're very heavily involved with, and kind of exploring what does that look like and what's being built. And I think from my perspective, I'm going to try and not cross too many paths here, but kind of just take a step back and look at the kind of overarching picture of what is Web3 and what does the future of the internet look like. And it figured there's no better person to ask than you, Rong. I mean, your background says, so much in your experience. So um, just kicking off, why is data important?
Uh, well, we have to go back to the history a little bit because of the internet in the past, right? The web, so-called Web 1.0, is a www web, and at that time, actually, most people still use personal computers, so-called PCs, and the websites apparently, provide information. More or less, it's a one-way information, right? People go acquire information from the web. But on the other hand, of course, the website could also learn something about you, collect some of your behaviors with the so-called cookies to keep track of which website you're logged on and what are your interests, etc. The Web
Sure.
2.0 is so-called a mobile web. So giving the illusion to consumers, we're holding a mobile web, right? While we log on to Facebook and Twitter, etc. As if we're actually the 2.0. Actually, there are a lot of so-called user-generated contents.
Sure.
The bloggers, the influencers, they produce some content. So as if there's an illusion, right? The audiences are getting the information from other parties, individuals, uh,
Yeah.
in addition to, of course, those websites or centralized information hubs. However, for the mobile web, actually, there is something hidden behind the scenes, so-called clouds. Put it vaguely, right? There's something. It's like it's there, but there's no clear boundary. But then that's why we call them kind of a clouds. And the data, of course, the user behavior, user-generated data are collected in the cloud. For example, if you're a YouTube influencer, you no longer own the copyright to your video anymore. It's the YouTube take it over from there, right? And similarly, like Facebook, of course, you believe you own the bloggers own the content, but actually they don't, because of, let's say, Facebook can decide to uh, to ban some of the account numbers or delete your contents, right? So in that sense, even though the contents are produced uh, by individuals, but then they don't really own their own copyrights or the contents. Well, now we're talking about the next phase, Web 3.0, where in a way it's still going back to personal compute. Some people, because to distinguish between personal compute, we call it PC2, and where you keep your own data. So PC2 actually is a software-defined. It's a virtual machine, basically. It's a software-defined machine instead of a hard case encapsulate hard drive and CPU. You can imagine there are similar things, but then they're all just software-defined. In that sense, you put the consumers or the individuals put their data somewhere, which is their own personal computes. And then they share with other parties without the so-called cloud hubs. That's the key differences, right? Then let's say if you're a YouTube influencer, you own the copyrights outright, and then you can broadcast to, let's say, 1 million audiences without someone just like take the ownership or in a way manipulating, like because the AI trying to so-called echo chamber feed, if you like, some information, so they just keep it feeding you similar information and giving you an illusion that you are correct about your perception of the world, that kind of thing, right?
Yeah, it creates the world you want it to do, and in doing so silos you, and then you get polarization of groups, and that causes all kinds of issues. I remember off what you're talking about with PC2s and kind of direct communication, you mentioned about how the internet today, we connect to a server, which we connect to our broadband, which connects to a server, and we are actually communicating with servers opposed to directly from our phone to another device. And if you think of an IoT device, for instance, like your Ring doorbell is connected to a server, and when you get an update, say someone's at your door, you're not communicating with your doorbell, you're communicating with a server off in California somewhere, and then they're storing that data and it's doing whatever they choose to. But also it creates a security flaw in that someone could access that database and then view your Ring doorbell or do all kinds of nasty things. So it is in what I'm saying is in the Web3 world, it's about how do we allow that Ring doorbell to connect directly to your phone, and if not, connect to your personal cloud where you store the data and then you communicate to your cloud, your personal cloud. Is that correct?
Yes, actually, physically, right? Technically, that's the case, and which is also important to notice. The other actually big important aspect of the internet, the past versus new, is that the old one, ever since actually the internet before the Web 1.0, it was the designers of the internet, right, decided the internet should be decentralized, right, should benefit the mankind as a whole. So it's free. Of course, there's initial funding from like U.S. government or from donations or contributions of corporations. However, until today, the internet is so-called free.
Yeah.
Right. Free meaning nothing is really free because of the employees has to be paid, regardless, right? Like Microsoft employees, Google employees, that's their job, right? To get paid. And so if the internet is free, how could like Facebook, Twitter, and Google, Apple make their money? So then basically they feed you contents for free. And then on one side, if you see quite a few newspapers, the media companies now no longer exist. I remember vividly, like 20 years ago, if you see, of course, there's always events all around the world, like wars, battles, some whatever, like Olympics, right? And happens. Yeah. And then you see the reporters actually in those cities, in those wherever the events happened, they were there, right? Yeah. That's their job. But then given we have the free internet, everyone has a phone shooting videos. And then now those newspapers, media companies, the authentic media companies no longer exist because they couldn't afford to they couldn't compete with the
It's amazing, isn't it? Because you have it's almost creative destruction, and it's you've got your Blockbuster versus Netflix story, where Blockbuster had some of the smartest people working for it, and they were, the brightest minds with a whole business, and they had a distribution channel which was physical shops all across the world, and that was their biggest asset. And then overnight, broadband speeds hit a limit where it surpassed where you could then stream, and suddenly their biggest assets became their biggest liabilities because
Correct.
they had all these shops. And creative destruction through technology, which as a deflationary force just gets more and more powerful, you have these new up and coming technologies which make the old redundant, and then they fizzle away. And we're kind of in seeing that in the Web3 space, where actually it's like, okay, we've got this own your own data from the ground up through digital identifiers and DIDs, and then all the kind of pieces that are coming together. And at some point, that's going to, the day that I start earning money from my data from using Web3 over Web2, I'm just going to look at Web2 and just say, what am I doing over here? And then I'm going to migrate across. And likelihood, the migration across will only be exacerbated by things like AI, robotics, and automation, which is making me do less work and reducing my labor to the extent where actually I need to own my own data to have a form of income, because I can then, by doing that, I can choose how I monetize it, but I also have security and privacy as well. So it's fascinating. And then, Rong, I guess the question would be, you mentioned in the recent Elation podcast about the Web3 tidal wave, the third wave is coming. So when you look at the big picture, I mean, where are we in the timeline? Are we 20 years away from real global adoption, or do you think we're a couple years? And the Web 2 as we knew it, it took a long time to emerge. And are we on a similar track to there?
Yeah, at least I think the technologies are pretty much there now. I mean, if we were not there, we're just like a year away from. Some people speculating it'll be at least 5 years. I'm more optimistic. I don't think it'll take 5 years, because 1 year at the most to see the beginning of a new era. But on the other hand, if we take www or the mobile web as a reference or two references, well, of course, it takes time for the whole community, for the world to get used to or adapt the new internet. Actually, the new internet, one important aspect of is, first of all, the old one was free, but nothing is free. So the new one, actually, there's a way, right, to incentivize the contributions and and make sure whoever published the contents, they're not copy cats. They provide authentic contents, and also they're liable. They have to be held accountable for whatever they produce. Of course, they also got paid. The old one was because it's a free internet, and then some media companies or the internet companies, they can care less about whether the media was genuine. But whatever get consumers' eyeballs, right? They got time for advertisement, and whether those contents were authentic or genuine, like a feedback. Are they real user feedbacks, or were they generated by bots, right? Because like some advertisement companies will just say, okay, if you sign me up, I'll help you get 1 million thumbs up, right? So are those 1 million thumbs ups are real? So those are the things. The old internet, a lot of players, they just don't care. They just keep on. So it's a vicious cycle, right? And the other thing is lack of governance, because the old internet, right? There's no ID. There's because the internet is a platform for mankind, for everyone. Because it's decentralized, everyone should have a kind of like human right, so they can log on to the internet. But on the other hand, at the beginning, the benefits is of course overwhelmingly better than the shortcomings. right? So because people get more information, but after 20 years, we realize it's not a internet's not everything's good. But then, so people debate, right, whether like a small government is good, whether big government is good, dictatorship is bad, but then democracy has inefficiencies. Regardless, everyone kind of agree we need to have some sort of governance,
Yeah.
right? Do you really want to, live in the wild west, and like the strong or the bullies will just take advantage of the weak,
Yeah.
maybe some people do, but then we need some sort of our governance. So what I'm saying is the old internet doesn't really have any governance, or some corporations behave like they are the government, right?
Yeah.
And then they take either Big Brother takes, okay, since the internet was so lousy, why don't I provide the protection? It's like a mafia on once upon a time, right, in New York,
Yeah.
and saying, okay, I provide the street vendors some protection, but then you pay me.
Yeah.
And so
Or else.
in a way, if you look at the old internet, that's the case, right? Shouldn't we have more like a community governance? That's where we want to stay because of different culture background, different religious, different geopolitical regions. I mean, you don't have to sign up, say, to this virtual country or that, but at least you have choices of different groups organized by communities. In the old internet, they are all organized by profit-driven corporations.
Yeah, it's really interesting the kind of shareholder top-down structures of where you need to enrich the shareholders, and with that, even if the company itself is doing evil, it doesn't matter, and it drives greed in a way which is actually quite yeah, it's not. I mean, it's destructive to the world, and we're seeing it kind of just psychologically as well, and the effects it had. Obviously, I've had the pleasure of on the council this year having Brittany Kaiser on, and she obviously played a part in the whole Cambridge Analytica side. And you think about the way in which elections and massive policies in the world were affected through big tech and what it's able to do. There has to come a point where those are broken apart, and it has to, in my opinion, come from the ground up through, as you say, community-driven approaches where it's all very grassroots and you give people the power, opposed to top-down kind of structures where everything's being dictated. But certainly, it's the wild, wild west at the moment. And I mean, the crypto, from my experience in the crypto space, it's getting better, but I'd still say there's a lot of toxicity in the space. But I can only imagine that in 5 to 10 years' time, regulation will catch up, and there'll be probably more order, because really what we're seeing in the space now is very isolated, and it's very just people who are kind of almost crypto geeks who know how to do yield farming and DeFi and play all these games. But where is it actually getting out to the real world and doing real world change, affecting people's lives in a really positive way? I wouldn't say it's there yet, but I think we're en route. And with that in mind, is there anything, a real world solution that excites you the most that you believe Web3 can fix?
Yeah, because of Web3, if you look one step deeper into technical influence changing the world, actually Web3 is not necessarily just a web anymore. If you see internet, Web 1, Web 2, they're just mostly connecting, right? I mean, the first one is before web, the internet, before 1955, but not 1995, it is just basically connecting machines. But since 1995, www web, of course, is invented a little bit earlier, but then 1995 was the year, right? The consumers sign up more. Basically, the normal folks are started to use the internet. Until right now, actually, there's a new term called metaverse. Whatever the term is called, actually, the connection aspect of it start to disappear. It's omnipresent. It's there, but then you don't realize it's there anymore. You start to see this, as I mentioned, personal cloud compute is like a virtual software-defined PC. But given the AR, VR, or AI, those technologies, and of course, given the Bitcoin and decentralized ID and put everything together, you start to see virtual individuals, right? Of you, like some people call it digital twins of you, right? That's one way you can imagine. You have an avatar in the cyber world, and you can achieve some do some chores or get some tasks, assignments, or jobs, and earn some profits over there. But of course, it's also going to direct influence the real life, because let's say you can have scarcity for movies, for ebooks, limited number of ebooks in circulation on the internet, so you got paid for your copy, and then you can have a personal ownership of a bookshelf of books, so you can pass on to your future generation, which was not feasible in the past. So you basically start to see the tangible real world map to those metaverse, right? So in that sense, you see virtual individuals, virtual properties, and digital properties, and virtual governments, those cyber governments versus the really 200 or so, the governments on Earth, right?
Yeah.
You see, you start to see tribes of, those gaming tribes, or some, let's say, cyber republic communities, whatever you call it, virtual country, virtual community. It's a gaming tribe, but then you start to see those things are happening. So in a way, we no longer talk about connections.
Sure.
We talk about virtual individuals, and also whether you call it a democracy or capitalism, because on the internet, we don't really have a personal ownership of anything.
Yeah.
Let's say Amazon has ebooks and Netflix has movies, but then if you purchase a movie from Apple, and then can you pass on to your future generation?
Yeah.
So in a way, there's this book, right? Wealth of Nations. Do we have this similar invisible hands on the internet? We don't.
No, you're
So
right.
those are the things really excite me.
That's awesome. Yeah, I completely agree. I mean, to have a free market on the internet is something we just don't have today. And that would, in having ownership and privatization of data in a way in which you can buy and sell it, you would unlock, I believe, trillions in as far as money, but also it would be true internet capitalism for the first time. And we're yet to see that. So I 100% agree with you. And it's funny, before I really got into the Web3 and kind of into the blockchain space, I worked in primarily film, but also kind of in the museum aspect of 3D scanning assets and turning them into digital clones. And it was along that path, especially in the film side, I'd have to scan both environments, but also actors and extras. And they would always ask me, because they'd signed a contract with big Hollywood firms, and they'd be giving away themselves essentially as a digital clone. And they'd always be asking, can I get a copy of this? And I'd say, no, sorry, you're not allowed. And likewise, they'd ask the bigger actors, and particularly would come in and actually hate us because we were taking data from them, and they just didn't. There were certain ones that just didn't want to even acknowledge us, and it was very interesting. But it got me thinking, this is wild in the sense that it is taking a piece of somebody and it's taking it into this digital world, and it's being held somewhere by someone else, and it could be taken, and I could, for instance, take that character and manipulate them in a way which is, not what they like, and in doing so, it's a breach of your own personal space. And I think that's what we need to see next, is the idea that data is a personal right. It's yours. If you create it, you own it, and that should be something that you can always lease out to others. So I'd like to think in my job of the future of a film, at least, is I would own a digital clone of myself, and I could get one done every couple months or every year, however I choose, and then I could lease that to the studios to do what they need with the CGI, because a lot of the stuff you see on film now, even the stuff you think's real, it just isn't real. I mean, it's nuts. But then with that, I would be able to earn an income for renting myself out in the digital world, and then I would bring it back, and So it fascinates me, and I agree. True internet capitalism on the internet is yet to take place, and if we can unlock those doors, that's a massive bonus for humanity. And also, it'd probably enable people to earn revenue and income in a digital world without having to take from the physical world, and that in itself might help with things like climate change, or just things where we have to kind of take resources. There's a new smart contract application, a new app called Apex. It's a new game basically, but you can farm these little creatures and you can battle them, and in doing so, and it's silly, but it shows just a proof of concept that you can create NFTs which you can sell. And now suddenly there's a whole group in Indonesia and Malaysia who are playing this game and actually earning good income, and it's, they're not having to go physically out and do things. They can just be on a computer and earn money, which is, and it brings up their standard of living, and it's borderless anywhere in the world. So I think it's a great start to be in.
Yeah.
Okay, so I guess the next one would be, Rong, your background is very heavy in operating systems. So it was, am I right in saying it was 1995 that you joined Microsoft?
I joined Microsoft in 92.
92, okay, brilliant. And in doing so, you helped with the operating system aspect and worked in the Internet Explorer. So just a very overarching question, what is an operating system?
Well, that's a interesting question. Actually, operating system is about, I would say very importantly, not going into technical details. One thing is operating systems is about security.
Sure.
And the other one is about so-called decoupling. It's I'll get into the 2 points. One is the security. Let's say you have on a PC, you can create like 5 individual accounts for your family members, right?
Yeah.
I don't know how many people tried. Actually, you could, right? Create give each of your family member a account, and then of course you have admin account, you have a regular normal user accounts, and then one user cannot read the contents or files of a different user. So put it very simply, right? Operating system will create sandboxes for niche individuals.
Okay.
Then every user has his own personal space to save their files, so-called data, and then the other guys can read them. And also at the program execution time, for example, on a Windows or Mac, you can create so-called multitasks. You launch several apps in parallel and developed by different vendors, right? So then the vendors, when cannot steal the contents or from a different vendor, right? Basically, it creates quarantine spaces for niche apps to run. The term actually that's created from the CPU. The CPU gives you so-called address spaces. Basically, that's the space you have. And if the one program crashes or has viruses, it won't affect the other tasks, right? Located in other address spaces. That's basically to switch between those address spaces, switch between the sandboxes. That's the main task, responsibility of a operating system.
Okay.
Right.
Okay.
Without it, you don't really, because it has nothing to do with the computation per se. Computing Of course, people brag about Turing theory, the Newman machine. Turing is about computing, how you conduct, how you run the program, basically, right? That's called computing. You run a program, you achieve, you feed in some input, you get some output, kind of automatically decipher Nazi code or word processing and scientific calculations. Those are called computing. But then if we talk about an operating system, right, we give you multiple sandboxes. Actually inside the sandbox, that's computing. Okay. So we have multiple computings going on in parallel, and the operating system kind of organizing you, and each individual got a fair share of computation time, got how much hard drive storage you deserve to have, that kind of thing. That's the main responsibility of an operating system. The second responsibility actually is also as critical, is creating a so-called decoupling or separation of some, let's say, basically provide a computation independent, or put them into like communication, security, other aspects of things which not necessarily part of computing, put them in different dimensions. Okay. Giving you an example, we all know a program basically is a computation, right? But then where does the network comes in? The network is part of the computation, or is the security part of the computation? Because people also talk about some impossible triangle kind of thing, which is actually very old debate, or very old kind of a paradox. Say, if you look at, again, I give you example from Windows, because Linux, for that matter, is not as obvious. It's still, Linux, Unix also has very similar capabilities. Like on Windows, you can create a C drive, D drive, E drive, right? You can have up to 26 drives actually without A and B. A and B were for floppy drives. But then we no longer have floppy drives. Basically, you have only 24 characters, C to Z, right? So you can have, basically you can have virtually, you can have 24 hard drives. Hard drive, what's a hard drive? It's a storage space, correct? Yeah. And the computing is a task running on your machine, but where this computation task fetch its data from which hard drive, right? And basically storage is one space and communication is another space. So if you look at that model, and then a C drive, what's the network protocol? What's the communication protocol for C drive? That's the question. Let's say you put in a USB dongle. Everyone knows what's a USB dongle, right? You put in a USB dongle, you can, automatically Windows will assign you a drive number. Sure. That's a E drive, F drive. And then you put in a dongle, all of a sudden a E drive appears. If you unplug it, it disappears, right? And also for the techie, they also are able to use a command called netuse to mount a remote TCP/IP drive, basically an internet drive, like home NAS from another machine in your office or in your home, right? You have multiple PCs in the local area network, and then you can mount another PC's hard drive as if it's your hard drive. the command actually is called a net use. So basically, you mount a X drive, Y drive to your PC using the TCP/IP protocol. Of course, the old hard drive, those magnetic hard drive, it's a so-called IDE drive, which is yet the default hard drive protocol. And then there's a SCSI, there's PCI, there's some other, like Apple has its own different kinds of communication protocols, and they have their own way of talking to the storage. And then what I'm saying is, if you see C drive, D drive, you don't really know which communication protocol the applications doesn't really know. Applications don't know what communication protocols the hard drive is using, right? So you can imagine. But on the other hand, without operating system, then you can see the web, because the web was invented to benefit the everybody. Then there was no operating system for the internet, because who is the big brother to control the internet, right? Because apparently in the old days, people would imagine, whoever designed the operating system is the brother of the machine, big brother of the machine, right? If internet has no big brother, then in a way there was no operating system. So if there's no operating system, then the internet apps have to rely on themselves. They're on their own, as if for defend themselves for network attacks, viruses and DDoS attacks. They have to defend themselves, and also they have to make sure other apps won't steal their contents, and so on. And if you look at www, it has a HTTP colon instead of a C colon.
Sure, okay.
Right? And C colon basically saying how many hard drives you have. HTTP colon or FTP colon, P2P colon, what do they say? They're just telling you, okay, I'm going to use this network protocol to access this website.
Okay.
So in a way, explicitly exposed the network protocol you're using for the browser, right? So that actually is one of the vulnerabilities of the old web, because if I know which protocols you're using, I may intentionally, last time when I talked to Elation Nations, let's say because you're using HTTPS, right, for so-called secure channel to talk to a bank, then could I deliberately write a virus into SSL so then I can eavesdropping on your HTTP protocol? If you let me know which protocols you're using, I'll basically spend all my efforts and hacking it. Right? And if you don't know, if it's agnostic, the communication is agnostic to applications. And first of all, you don't know which route I'm going, right? To access the internet from point A to point B, which route I'm going to take, which program to use. And also, can I use multiple? I send 99% of my packets through broadband. I send just my keys through telco, right? To in parallel to hijack, to stop all different protocols at exactly the same time. It's extremely difficult. This idea is called a CDMA, right? That was who was the inventor, right? That's the Lamar, the actress, right? The famous one. CDMA was invented by a movie star.
No way.
During the Nazi era, World War II, and she has those math talents, but she happened to marry some rich guy and take some notes and listen to some high-level secret talks. So she just kind of invented CDMA, the communication protocol that we currently use for the cell phones, with a piano, with a composer. Because she was a movie star and she worked with the composer, and then two of them invented the technology and eventually being used by US Navy for submarines, so the Nazis couldn't decipher their information because they jump from communication channel to communication channels. It's extremely hard to intercept all channels at the same time.
Yeah, it's fascinating.
So this idea is called CDMA. And what I'm saying is, if you don't know which channel I'm going to send my message, I'm jumping channels, right? And then in that regard, because I was lacking of a network OS, then we see the vulnerabilities of the internet.
Okay. That brings us on to the next question then, because what is a network OS in comparison? Would it be taking the same concept of what an operating system is, but just putting it onto the internet? So you could have your storage, your different drives, and then your motherboard and all these different components, but it's split up across the world. Is that?
Yeah. Well, then we're talking about the network OS, right? As I said, before Bitcoin, before blockchains, who is going to control the internet?
Yeah,
that's a big holy grail question. And now with the enlightenment of the invention of Satoshi, and shouldn't we have a blockchain being the underpinning, so-called trustworthy, right? The source of trust. So in a way, everyone or all the governments in the world, if let's say US doesn't trust China, China doesn't trust US, and a lot of countries, European countries don't trust US or neither or China, right?
Yeah.
But then, can we at least all agree? Can we trust the internet? Right? If you see the Chinese government is cracking down on Bitcoin, and US was cracking down on Bitcoin, and at least we know it's not controlled by neither Chinese or Americans, right? Can we at least have that consensus and build our trust? So then we know Satoshi disappeared, and then out of Bitcoin or other reputable public main chains, we can issue so-called internet IDs.
Yeah.
Or decentralized IDs. At least we can rest assured, this kind of IDs doesn't have a big brother behind.
Yeah.
Right. Given this ID, so issuing ID, actually, that's one of the key responsibility of operating system. You log into Windows, you log into Linux. As I said, Windows can, you can have 5 users. 5 users each have their own unique IDs on the machine.
Yeah.
Right. So then, who assign the IDs to those users is the operating system.
Yeah. Okay.
And also, given you have an ID, and then the reason why operating system can prohibit one user from accessing the data of another user is because of they have different IDs, right? And the operating system will enforce, okay, the other space belongs to user B, and you are user A. You can't go access the data from user B, okay?
Yeah.
So given the ID, that's the first thing, because the operating system can distinguish user A from user B. And also, operating system can use, let's say on Windows again, there's a technology called BitLock. BitLock meaning you have a hard drive, and then if I'm user A, I can encrypt my data using my ID, private key, to encrypt data and put it on hard drive. Even you are the administrator of the machine, right? let's say you can read, you just take the hard drive out and mount it on a different machine, you can decipher the data I put on this hard drive because it's encrypted with my unique ID.
Is that almost like PGP encryption? Is that
I don't really know the PGP, but basically with the ID you can encrypt your own data. Even the admin, other users couldn't decipher, right? So which is a next step. Of course, given my ID, if user A wants to send a message to user B, it's public key. They can use public key, private key to encrypt the message and send to, let's say I can use user B's public key to encrypt the message and send it to user B. User B uses his private key to decipher the message, right, on a PC. So we extend this concept to the internet, given the blockchain assign creating IDs, right? Because if you have a wallet, I can send you a Bitcoin, meaning you can receive it, and meaning you are the owner of the Bitcoin and uniquely identifies you are the owner. So using the Bitcoin public key, I encrypt the message, I send it to you. You use the Bitcoin private key to decipher the message. Basically, we're doing a peer-to-peer communication channel, right? We can talk to each other. And of course, using your private key, you can encrypt your data and save it in Google Drive or Microsoft OneDrive or Dropbox. Rest assured, even Microsoft couldn't decipher, or Google couldn't decipher your information, just as if you encrypt your data on BitLock, right? BitLock Drive, then you are okay.
Amazing.
So
I mean, that really is.
Yeah, so it's not really we have to resort to IPFS or Filecoin for this kind of personal storage. All you need actually is the ID and your public key and private key, right? And so then you can create, as if Windows can create 5 users on a PC. Can we create 5 billion user IDs, and each one of them has a unique sandbox, encrypting their data somewhere on the internet and sharing them, as if on a PC 5 users can share data among themselves, but then on the internet can have 5 billion, even 100, 10 billion, 100 billion, right? We're not that yet because the whole world doesn't have 100 billion yet. We can, in theory, right? Everyone can share data with one another, very similar to people share data on a PC, because of 2 engineers, 5 is so-called a limited constant number, and 5 billion is yet a bigger, still limited finite number. So 2 engineers, 5 and 5 billion doesn't really have a fundamental difference in theory. They're the same thing.
Yeah. It's brilliant. I mean, there's so many different avenues I want to go down right now, but let's carry on in this direction, because actually the scarcity, I mean, value is found in scarcity. And we could say, okay, well, in the monetary system, we've got an inflationary problem where governments are manipulating and they're able to almost break the trust. So you have something like Bitcoin come in, which blockchain, as I would always put it, it facilitates the distribution of trust from one source of authority to multiple sources of authority. And in the most easiest way of saying it, it's just a trust mechanism on the internet. So it enables us to say there will only be a certain amount of units and that can't be manipulated. So then when you're dealing in that currency, you're dealing in a free market now because it can't be manipulated. What I would say today is we're not in a free market on the basis that the underlying currency is we're getting double taxed essentially through new money being put into the system at exponentially higher rates to try and keep up all the GDP growth that's going on. So then moving over into the internet, we have an inflationary problem in that I can just copy and paste anything, an MP3 file, whatever it is, I can copy and paste it and send it off to someone else. And there's no scarcity, so it loses its value. So if we can turn all this kind of data into code, where in order for, so as you say, you turn it into code and it's attached to my DID. In order to open this song, this MP3, which is now like a program or software, I have to double click it, it opens, and the first thing it does is it checks against the trust mechanism, which is the DID, digital identity chain. It says you are the owner, and it opens it up to me, and I get to enjoy listening to it. Now, if I sell that to someone else and they buy it, I transfer on the blockchain, on the trust mechanism, ownership over to them. So now if I had that same file on my hard drive, whilst I still have it, and I've sent them a copy, when I try and open it now, it goes against the blockchain and says, you're not the owner, you can't access this, as the person I sold it to can. So now all I've got is something on my hard drive which is taking up space, and it's useless to me, so I'll delete it. And in doing so, you create scarcity on the internet, and that creates so much value. And that, to me, I mean, when you talk about a network operating system, that to me is what that represents, is the ability to create scarcity through data and the ability to trade that with each other.
Yeah, basically, you talked quite a few concepts and things. Of course, let's go talk about the scarcity of data. Well, a lot of people right now, because I'm really encouraged and excited to see the popularity as gaining ground of those NFTs, right? Those non-fungible tokens. Basically, it's artwork, and or down the road it'll be music, it'll be ebooks and movies and health data. They can all be made so-called NFTs. Like even one of the projects in the Elastos community, like Creta, trying to create a credential NFT for each individuals. So basically, any kind of data you can generate a NFT unique, right? It's pretty much like every book has a barcode, or every merchandise you get from a supermarket got a barcode to identify this is a merchandise. The other aspect is actually data actually is a blob of digits, binaries, right? And then if you run it, if it's a data file, the old definition of data file, like on a hard drive, you have two kinds of files. One is a program, the other one is so-called data files. All right, like, okay, you have Word, you have Doc, you have Acrobat PDF reader, then you have PDF. You have a media player, and then you have H.264 movie. And one is the player, the other one is the contents being played. Right. So by and large, you can basically put all software into the same paradigm. Like Word actually is the documents player. Right. It's a media player to play the Word doc files, or the PDF reader actually is the player for PDF files. Right. Similar to like a multimedia player play multimedia.
Sure.
This concept actually, again, come from Turing and Newman era. You load program first, then let's say on the PC, you double click on Word, and then you launch Word first. Then you open up a data file and launch the data file second, right? That was dated back like almost 70, from around the late 40s. So about 70 years, more than 70 years now. But now, if you think differently, can we encrypt it or package data as a self-extraction, self-executing binary, which is a very easy tool. Basically, you make a movie, and then movie is a data contents, then you scramble it and put it in the executable file. Then with the big data encrypted built into that binary, then the binary runs. Basically, you can imagine a game, right? You launch a game, the game does nothing but just play the movie and pause and fast forward, fast rewind.
Sure.
because the fast forward, fast rewind is a template that one can apply to any movie content.
Yeah.
But then you merge the two into one piece. You run it, right? As a game play itself. So you can watch a movie, you can read an ebook, you can do pretty much, read your Word document. But on the other hand, the difference is that should we trust in the old operating system model? Should we trust media players? Basically, that's a generic question. Should we trust apps?
Okay.
At all, right? Basically, as I said, Word is an app, but then can we trust it? Media player is a app. Can we trust it, right? Because let's say I made the video, H.264 video. Can I trust the media player which renders me, right? So then, what if this media player doesn't it's not abide by the DRM regulations? Basically, the media player chose to ignore DRM. What I'm going to do, right? DRM stands for Digital Rights Management.
Okay.
And of course, there are some regions, people make those media players to do piracy and to play contents without paying its dues. Then now we're talking about merging data with code. It's not that hard. And also it won't increase the size of the program that much, because of all you need is just a little bit, a few kilobytes of so-called header, executable header. All the codecs will still be as what it is today. So, those kind of new files will be just a few kilobytes bigger than the old ways of doing things. But then when the data files start executing, it can go to the blockchain to validate, are you still the owner? Do you still have the right?
Yeah.
Right. This idea is not hard to imagine, but the hard part, again, is that viruses. You can encrypt the data today on Windows or Linux. You can send them through email. You can through the social channels, right? As I said, make a little video and make them into executable, and as attachment, you send through email to me. But then everyone learned its lesson hard way. If you click on those files, your PC will get on, more likely get infected by viruses, correct?
Yeah. Yeah.
So it's not that we cannot make data into executable. It's not that we cannot share. It's that the old operating systems cannot fend off the viruses. So then we cannot spread data as code. So we need to have new kinds of virtual machines to run data. So in a way, if you see WebAssembly is a browser and dedicated a section so-called WebAssembly executable space that runs, that's a sandbox, right, to run some binary within your browser.
Yeah.
So follow that line. You can imagine, you see a lot of crypto projects are right now adapting the WebAssembly. Yeah. So WebAssembly is that kind of virtual machine. Then you can run I call them digital capsules. Yeah. Because of if you share, let's say, a link, a movie link, whatever, it looks like a capsule.
Yeah.
Right? On WeChat or other like Telegram, it looks like a capsule, and with a little introduction, with a link, with a little animation, picture to basically get you interested, and you click on it, and then the capsule opens, the movie play itself. You can imagine this capsule is this kind of NFT, binary NFT, a self-executable NFT. And then it won't trust any media player, but some, say, a browser, which is behave like a virtual lightweight operating system. the WebAssembly execution environment actually, you can treat that as a very lightweight VM virtual machine, and then people can audit the source code and make sure the producer of because after all there are only 2 or 3 major browsers, limited number.
Sure.
It's not like, okay, apps, you have so many apps, right? Word, Acrobat, the game, there's no way you can audit all the source code. You can, make sure all apps are following the rules. But then if the number is very limited, let's say 3, then enough geeks will go read the code and make sure they won't steal our data. So that's why the difference between a little VM versus app. So then all the apps will run, or the dApps or the digital executable NFTs will run inside, let's say, WebAssembly, or we were trying to invent our own Elastos runtime. Basically a similar concept, right? Whether it's a standalone native runtime, or we use a popular mainstream WebAssembly to achieve the similar effects. Basically, maybe one is slightly more efficient than the other. That's about it. But then the current problem with the WebAssembly is that it's not that they don't have a VM. It's if you launch a WebAssembly inside a browser, the browser will dictate if you get the WebAssembly talking to a website, that's the only channel you have. You basically, the WebAssembly cannot randomly access some other WebAssembly from another client. Okay. So WebAssembly always, browser always go back to the portal.
Okay.
Right, and then if that's the way, what if the portal behave, doing evil?
Yeah.
Or you're saying, okay, we're not have a website portal. We're going to have a DAO. We have a decentralized portal. We have a DAO over there. But collectively, those DAO, could they be evil? Do I have a choice of not using this DAO? Because as I said, the WebAssembly browser has only 3, let's say, from Google, from Firefox, from Apple. Even Microsoft gave up using Chrome engines. If we have only 3 players, or there's a WebAssembly from some website, Facebook, and so matching, basically going to the Facebook website, is website or cloud. Is that how about we decentralize TikTok like Dfinity, right? Dfinity could be evil, or Facebook could be evil. How about we decentralize Facebook? How about we decentralize TikTok? But in that regard, still, it's not pure peer-to-peer, because I want to talk to you. I don't want to talk to you through a company or centralized company or a decentralized DAO. I just don't.
Sure, yeah.
Right? So that's where can 2 WebAssemblies directly talk to one another without going through a DAO? That's the another question. That's why you see we have a so-called Elastos carrier.
Yeah.
Because we have to build a network instead of a kind of centralized or decentralized center. So when people talk about decentralization, it's not really centerless. It's not really peer-to-peer. There's a subtle differences there, right? So I want to talk to you. That's peer-to-peer.
Yeah.
And then if we're saying it's a DAO, let's say Ethereum has a 10,000 supernodes. That's a DAO.
Yeah.
Do I have to go to that 10,000 nodes? Even though they're less likely to be dictators, but collectively, could they still be dictators? right? Don't forget that's an organization. They still can decide to do something collectively.
Yeah.
Right. So don't tell me, you know, there's a internet nervous system or there's a DAO, then they couldn't be evil.
Yeah, it's funny because yeah, I mean, in DAOs and, as you said, the internet nervous system, it's reliant upon tokens. And in a lot of cases, what I've found is there's a monopoly on who owns the tokens as it is. So if someone wants to be malicious, they can be. And yeah, it's always interests me to look at the tokenomics of different projects to understand, you know, to what allocation did they give to who, and what's the vesting schedule, and how they could then potentially abuse that power, because absolute power corrupts ultimately. And given the opportunity, it's in human nature that they would. So having that opportunity to have a peer-to-peer network where I could just connect with you, Rong, today on this call without us going through a website, without going through a browser, operating system to operating system, and using the carrier network, which we should probably elaborate a little bit more on, because there's over 200,000 nodes right now that are active, which are a means for routing your messaging through. Is that correct?
Well, yeah. Let me clarify. We do have about 200,000 set-top boxes running the old versions of carrier right now. Basically, when we did the first version for carrier, we did some experiments to see can we launch 1 million. Actually, we hired some third party and launched 1 million set-top boxes. Currently, there are about 200,000 still running. But then those are, and also our partners did some experiments like content delivery to use those 200,000 set-top boxes as a content delivery network, say to achieve a lower cost to do the logistics, right? To do 4K video on demand, to do video conferencing, that kind of tasks. Yeah, we, I mean, our partners indeed give us some feedback and have some data on it. But then they're mostly test beds. They're not real use cases, doesn't have like the feeds or hyper or profile real users yet, right? Otherwise, they have to upgrade to, let's see, DID 2.0, HAF 2.0. At this point, we take a more realistic stance, like, okay, if there's a need, of course, we can very quickly going up to 200 million. But then at this point, we don't see, we basically will grow as our market grows. And the other point I want to make is that Elasto's carrier, again, is open source, and it's a reference design. And I personally don't believe Elastos will be the only player on Web3. Even we call it Elastos Smart Web, Web3.
Sure.
Elastos carrier shouldn't be the only player. That's why in the Elation interview, I mentioned down the road, we're going to demonstrate so-called decentralized carriers, right, for business. Basically, the model is more like internet email. Let's see, internet email, right? You have Google Mail, you have Yahoo Mail, you have Microsoft Mail, you have Apple Mail, right? Or if you don't trust anyone, you can have your own corporate mail. You can have, right, build your own. Some group of geeks build their own mail server that you have your own mail domain name. But then the important point is, so then every email server an email client can talk to email client from a different party, from different developer, vendor, right? So then, like, okay, if you receive the email, you also receive a notification.
Yeah.
Oh, okay, you got mail. Then in that regard, do you consider AOL, right? You got mail. Is AOL a centralized company? But then the real question is, do you trust AOL? Right? So AOL indeed it was a centralized company. But then if you trust it, then it gives you a notification, say, okay, you got an email, you got a mail. In that regards, that's more realistic perspective, point of view, right? To approach the web. It's not really, everything is rely on yourself, it's a decentralized, because of everybody trust somebody. Let's say you trust your family, or you trust, a colleague, or basically you pick someone you trust, or some organization. If you don't like this country, you go immigrate to another country. You have to find a place to live, right? You can't say, I don't trust anyone. I live in a cave. I mean, potentially you could, but hardly anyone, right? Pick that extreme stance. So in that regard, we are going back to that kind of user experience. So then remember not long ago, like any peer can talk to hyper, so in a way that's the email model, right? And then for the IMs, but which is definitely different from the mobile internet. If you use let's say WeChat, talk to each other, everybody has to be on WeChat. If you use Facebook to talk to each other, everyone has to be on Facebook. You cannot talk from a WeChat user cannot talk to a Facebook user. So which is obviously the shortcomings of mobile internet, because it divides people into kind of fenced gardens. Right. And those are the, let's go back to Web3. Everyone, if, of course, WWW consortium, so W3C for short, they collectively, there's a consensus, people there define what's a decentralized ID protocol, that Elastos implemented that protocol. Again, also implemented that protocol, and also many other organizations implemented that protocol, right? Even everyone's complying to the standard. Regardless if it's
Wrong. I'm gonna have to stop you just for a sec. If you can hear me, okay. I think there's it sounds like it's all going on in the background. I've got I'm not sure. It's got birds talking. They're having their own podcast and a helicopter. But your sound went for a moment. So if you speak now, are you back?
Yeah. Basically, what I'm saying is, people should have choice. Instead of always my communication always go to a DAO, then going to you, or always going to a centralized company and going to you. Of course, they can have Elastos carrier, but then do they have a choice, pick some other decentralized peer-to-peer network in the future? Or because of Elastos open sourced, then one party can implement so-called ELA.net. The other party could implement, given the source code, they basically fork the source, or add new features to the source code to build, let's say, PC2.net carrier. So then the user could have a choice of which DAO I'm selecting, which carrier I'm using, decentralized carrier I'm using to reach you.
So what you're saying is you could have different URLs which you access, and they could be a different route of, say, thousands or dozens or whatever nodes, which then takes you to your destination. But you could pick between just different ones based on different access points. Is that correct? So
yeah. And also it's no longer called a URL anymore because of its like Tor address. Or basically, or the Elastos DID. Basically, it's just a 256 digit number, right? So which is an important distinction, because of if you pick a URL, of course you can still pick a URL.
Yeah.
If you pick a URL, right, and then there's a domain IP address, that could be a DNS pollution, there could be a Great Firewall block this URL, or middleman attack, then you're liable, or vulnerable, susceptible to attacks. But if given you have a Tor address or 256 ID as a address, you can have, let's say, the difference is not only I can hire, if I trust, let's say, ELA.net, right? But can I trust the ELA.net and PC2.net? Can I trust both? And can I trust Tune.net as well, right? Or I trust Tor. So I can pick several routes, sign up, and to publish my blogs. Or you can use Tor address to get to my Raspberry Pi, like Lightning Network. Or you can go through Rong.Chen.ela.net, right? Basically, you use Tor address or use Rong.Chen.ela.net, both get to my Raspberry Pi at home.
Yeah, interesting. I mean, it's fascinating. And I guess looking at the overarching, if I look at the Elastos Web3 tech stack at the moment, I'd say there's obviously the digital identity aspect, which Ryan from Starfish kind of termed in a really nice way to kind of understand as one universal identity owned by you. So where we have all these different pockets and we have to go to different websites to access, and it's all siloed and owned by companies. In this Web3 environment, we have this one digital identity. You own it, like you own the seed phrases to your Bitcoin to a wallet, you'd own it the same thing to your identity. And then with that, you can control endpoints as far as you can control the data you produce and also who you communicate with and other DIDs which you allow access to. So that's one big piece. And then the other is the carrier, which we've just kind of talked now about how you can communicate directly with each other. Hive is the other one, which is a layer 2 storage solution, if I'm right. And it means in which you can pick, again, because this is Web3, it's all about having the choice as an individual and being empowered. You could pick places where to store your data, be it on your personal PC2, your drive at home, or on Google, or on wherever or in a node, whoever you decide. And then what else am I missing? So there's the runtime, which is kind of moved away from that, and that will return down the road. And then the big other part would be the smart contracts. So obviously we're seeing the whole space explode now with different projects doing different smart contracts. And whether or not that's all correct to be building a whole Web3 as if that's just about smart contracts or not, we're yet to be seen. My question to you is the future of the internet run on smart contracts?
Well, basically, what you mentioned, elaborate all those features, or they're all part of this so-called Internet OS, the Web3 OS or Smart Web OS, I used to call it. They are technologies or tech components of a whole, right? So then, like Linux, open source, everyone can take Linux and make their own distributions, like a Red Hat distribution, Ubuntu distribution, Debian distribution, and Microsoft even start to make its own distributions of Linux, right? So then I want people to remember open source, the network OS is to have choice. Internet is to have choice. Even though some organizations are reliable, you believe them today, but then down the road you don't know. So definitely, whether it's a company or a DAO, people should have choices. That's the network way of looking at things. Looking at a network, right? Versus looking at one company, centralized or decentralized. So definitely that's we can't emphasize enough about the Elastos difference from other crypto projects. We are very thankful to other crypto projects because we borrow heavily from Ethereum. Of course, we used to run the Neo smart contracts, but now we are running Ethereum smart contracts. Down the road, I'm also looking forward to running like a Definity smart contracts.
Nice.
It's not what we're looking forward to. Doesn't mean I have the program. In theory, you could, okay. But unfortunately, I don't really program that much anymore. And I'm just basically saying I will encourage our community or other communities, like even Definity. We should all work together to build this new internet, right? We shouldn't say, okay, being exclusive, saying we are the new internet, you are not the new internet. Actually, collectively, we're building the new internet. That's very important.
It's quite funny, isn't it? Because actually, crypto as a whole is so tribalist, and there's so much tribalism in where we're attacking each other, but actually we're all in it together. And the irony will be that right. We'll all succeed together as well in different ways, and we'll add different elements. But it's like, no, it can only be us, and everyone else is going to die, and that's the end. And it's like,
that's not the because if you see the web, right? Tim Berners-Lee invented, and Netscape took over, and Netscape went under, and Yahoo became popular, and Yahoo, went away, and then Google, Facebook took off. Basically, the web has a life of its own. It's not Yahoo's life, right? I mean, the web is not equal to Yahoo. It's not equal to Netscape. That lesson we have to learn, we have to embrace. Then coming to your question about smart contract, the future of the new internet. The question, basically, in my opinion, what is a smart contract? So smart contract is just a fancy name. It's just one kind of a program, right? When we were in college, or even when I first came to US 1984 spring, at that time, US colleges, were still using IBM 360. Basically, it's a mainframe computer doing so-called batch programs. Batch program, it's pretty much like a Windows shell. You run them. What's a batch program? Batch program meaning not interactive. The current younger generation, people are used to so-called man-machine interface. Windows, you tap using mouse, using keyboard, you tap to, basically you interact with the computer, right? That's interactive. The modern operating system, the man-machine interactive operating system is called Unix. Unix was started the project 1970. Internet was started December of 1969. So they're more or less around the same time frame. Yeah. And they both matured after a little bit more than 10 years of research. When I came to US 84, they both matured. TCP/IP became the de facto standard of the internet, and C programming language became the native language for Unix. Basically, they were not the first incarnation. They were just basically several iterations later, right? Then open sourced to universities, like a University of Illinois can get Unix source code from Bell Labs. And we also got the source code of TCP/IP from the internet communities. Yeah. So what I'm saying is that batch program was not interactive. Batch meaning you have punch cards, right? You have punch cards, paper, tapes. Then you have the stack of punch cards. You hand it in to so-called the machine room or the computation center, then you won't get results until several hours or a day after. Basically, you wait in line. You wait in line, right? You hand in by, priority. Somebody is more important, or poor kids, students. Just we line up. Then you hand in your homework like that, right? Like paper tape when I was at Tsinghua University in China. Then a day after you come back, then the operator will give you a pile of printouts on paper. Then you see, oh, do I get the correct result back? Then should I make a reservation, modifications, and hand in another roll of paper tape?
God,
right? So basically, that's called a paper tape or a roll of paper tape or a stack of punch card. That's called a batch, right?
Yeah.
Naturally, and then. And also at that time, because hardly anyone's doing gaming because of the computer time were precious. And at that time, the batch programs are more likely, actually almost 100%, are called deterministic for scientific calculations. This is a fancy term. What's a deterministic? Meaning, oh, you have this program, then you have a pile, another roll of paper tape or stack of punch cards. That's your data. You want the program to calculate, right? You have your program, then you have your data. Then the operator will load your program into the computer, then load your data, then print out the results. Deterministic algorithms, meaning, if your program perform as expected and you give this set of data, the printout will always be the same. That's called a deterministic. Basically, like a 1 + 1 always equal to 2.
Sure.
Right? That's called, because for scientific calculation, you need that predictability.
Yeah.
And but on the other hand, for gaming, you have random numbers. Because it'll be no fun if you play games, always giving you the same prompts and you always achieve the same result. You'll get bored very quickly.
Yeah, for sure.
Right? So then, like a website can do A/B testing. Depends on who you are and depends on your previous data. The website feeds you different contents, right? Yeah. It's not really random, but it's unpredictable to me, to the user. Yeah. So those programs are called non-deterministic.
Sure.
And what I'm saying is a smart contract is a deterministic program. It's a deterministic batch program. So basically, a smart contract equates to the batch file in the 60s and 70s. All right, because the reason why it belonged to, first of all those programs executed in the 60s and 70s, like scientific computing is still a big part of modern life. Let's say Elon Musk or Jeff Bezos, actually, for that matter, going into space, right? That program is just a little bit more complicated than Apollo 13, right? Yeah. But on the other hand, they're same kind of programs, launching a rocket. So what I'm saying is the programs in the 60s and 70s, they are actually more essential. They're important set of programs, right? If human needs to invent programming or computers, they must first do batch programs or those deterministic scientific calculation programs. I'm not saying they're not important. I'm saying because of their history, they're actually more, they're more fundamental. They're essential to our future. That lays out the new foundation for the new internet. But on the other hand, are they a majority? Are they the mainstream of programming? Now you see where I'm at, right? The foundation of the internet is important, but more users are doing gaming. More users are doing, this mobile, whatever, Uber, search, Amazon, right? So human interactive. And so definitely what I'm saying is smart contract will not be the mainstream programming for the new internet, but they're the fundamental piece, the foundation piece of new internet programming. They belong to the infrastructure building. They belong to the new internet building. They don't belong to the apps.
Sure.
Right, like they belong to the below operating system. There are also infrastructure building, like the internet. Is internet part of the operating system? It's not, but then internet is actually part of the infrastructure system programming community. And so basically I want to say where is the smart contract in the big map, in the big picture. And then the smart contract is different from batch files after all, because the batch files were executed on IBM 360-like mainframes or Cray supercomputers, which I used later on, like 87, when I was,
in
at Illinois, basically the machine every day crunching out scientific data, right? And so at that time, most of the Cray computers handle only batch files, not human interactive. Basically, you hand in tasks, you get it sometime later. You don't directly interact with the Cray computers.
So do you? So I mean, that's another question. But do you then see the supercomputers back in the day almost as a parallel to the smart contracts today, given that there's
the uniqueness,
deterministic?
The smart contract is still deterministic, but the difference of smart contract from the Cray computer programming is that the Cray computer or IBM mainframe computer, they run by a single machine. They don't run by consensus.
Dozens of nodes, yeah, sure.
Right. Whether the batch file, as I said, you hand in a task, it'll give you the printout, and whether you have a bug in it, right, or you have some, sometimes it's called logs, some kind of a random bugs, right, like contention, because if you have multi-threads, and then someone could corrupt the log and corrupt the data, so giving you unpredictable results, which is not what you expect, but they happen, right? Especially in the parallel programming world. Now with the smart contracts, it's the blockchain is more or less for building trust, not for gaining speed, not for performance. Then it's like accounting, right? If you have auditing, so your accountant, you keep track of your ledger, and the auditing will inspect, will ask you questions, and you have to prove yourself, right? So then convince me, say I'm the auditor, and how do you convince me your calculation is correct? Should I run the same program along the side and get the same result, right? So then that's check balance each other. And then definitely I see a great needs after the Bitcoin blockchain. We do, because Bitcoin has a programmability, has some sort of smart contracts, but it's not, doesn't have a loop. It's not as versatile, flexible as the Ethereum smart contracts or Neo C# smart contracts.
Yeah.
Right. So then you see the like for crypto coins or currencies, programming currencies will have more flexibility for their applicable fields. Then given several nodes or tens of thousands of nodes check balance each other, of course, more nodes you have, less efficient you are going to be. But on the other hand, maybe that's required because let's say if we are for e-commerce buying a pair of shoes over another individual, do we need like 2 nodes, 3 nodes to verify, right? To escrow the funds. Maybe 3 nodes is enough to verify being the escrow, right? It's good enough. But then for more important mission critical apps, like 2 nodes is let's say Facebook is making DM or whatever currency. Of course, all the participating central banks they need to take part in the verification, right? Definitely, it's not going to be 2 or 3, maybe 21 or 100 members for Libra, the original design, right? They need 100 validators. So that's basically up to the application, how many validators, arbitrators they require. Let's say definitely you can say, I'm this kind of smart contracts, I require 7 arbiters, and then the other one I require 21 arbiters because I'm more mission critical. Definitely, if you see that where it's going, it's a good idea. Actually, the infrastructure need this kind of programmability, and to launch consensus algorithms or sidechains depends on the application, right? What do you require? So then, of course, there's a need for not only running this financial-like smart contracts, because batch file can do like scientific calculations, can do a lot of things beyond financial markets. Right. Take that as another into consideration. Then you'll see, do I trust if this program runs long enough? Let's say both of us trust this program, and even one node running, as long as you can prove to me that's not your node, not my nodes, it's a escrow's nodes, one node, correct? If we're okay, then we are okay. Let's say we bet $100 on a Olympic star, right? Who is going to win the 100-meter dash? Let's say who is win the soccer game, and then is that super important, or just $100 or $200? So in that regard, so long as the node is not yours, not mine, and that's fine. In that regard, do we really need a consensus, right? The consensus is we're picking a node, randomly, launched from, let's say, Elastos carrier. That's good enough. So in that regard, in the speed of this kind of deterministic algorithms could be, performed on par with the single machine, single cloud. I don't see why not, right? This kind of node has to be run slower than one cloud or one node, one machine. But on the other hand, I don't see it's going to be faster than one node or one cloud, because one cloud is a different kind of programming, which is called a parallel programming. Parallel programming meaning more nodes, they divide and conquer, then they work in collaborations to achieve better performance. But the smart contracts, they are for check balance. They are for predictability, for deterministic, right? And So basically, I'm talking about two different sets of programs. One is so-called parallel programming. That's the name used for tens of years through the 80s until now, 40 some years, people talk about parallel computing. But just because of the blockchain community doesn't know better, then they sometimes use a term for the parallel programming or distributed computing. That's really confusing because of previously the computation communities have already used the two terms, distributed computing and parallel programming. And then consensus programming, smart contract, they're new terminologies. They're okay, whatever you call them. But in the past, nobody's using those terms. So it won't cause much confusion. Then the consensus programming is to check balance. Check balance means it takes time. It's not going to be as fast as one machine. Say one accountant keep track of the ledger, then you ask another guy to do the auditing. The two guys together, is it going to be faster than one accountant, or is it going to be slower? In the worst case, you trust that accountant to be accountant and auditor, you're just still one person, correct?
Yeah.
So you're not going to be faster than one person. That's not the intent. The intent is if there's an auditor or randomly pick a accountant, we have more trust.
Yeah.
It's not for scientific calculation. That's for getting the job done, right, more efficiently. And this is we can trust. So just saying mixing the two, confused about the two, won't get us anywhere.
Yeah. Yeah, no, it's super interesting. I know Vitalik recently came out to say, he's looking forward to the innovation that will now start to emerge beyond DeFi because it can outreach further. And also then watching regulators talk about how they're going to regulate, the blockchain space, not realizing that obviously the fundamental difference with smart contracts is when you write the code and deploy it, that is deployed. So, there's thousands of experiments going on today with different smart contracts, and then you see the winners which emerge currently mainly through DeFi and NFTs. But actually, they're out there and you can't stop them now. So it's going to be very interesting to see how regulation moves forward in that regard. So we talked a little bit about the smart contracts and the speed in which they can kind of operate and whether they'll be adopted. I've heard you say in previous interviews and talk about Amdahl's law, if I'm pronouncing that right. Would you mind just elaborating a little on that?
Basically, Amdahl was the chief architect of IBM 360, which is a milestone, was a very successful project. A mainframe from IBM. Amdahl was the chief architect for IBM 360.
Okay.
And in the 1960s, I forgot, 67-ish, he came up, because at that time, the mainframe was trying to achieve better performance. And then they started to do parallel programming, and also they started to have the concept of VM, virtual machine, as early, right, as 60s. They start to have those concepts, which influence lasted until today.
Yeah.
The Amdahl's law was just saying that, okay, if we have two computers and doing two unrelated, or two CPUs doing unrelated tasks, and we can get, of course, we can get better performance, but it's really a no-brainer. It's not for discussion, right? Yeah. Let's say one machine is doing search, the other machine is doing machine learning or doing word processing. And you say, okay, this machine is a billion transactions. Billion is too big a number. Let's say 100,000 transactions per day, per second, and the other one is another 100,000. But actually, if you have more computers, of course, you add it up, and then how many transactions can you do? But then it's irrelevant because they're doing completely two different things. right? So that's
Yeah.
why you'll never get you'll never get people ask, what's the TPS for internet? Because on the internet there are so many computers, and they're doing completely independent things. Many of them, right?
Yeah.
Doing anything. But then if you just time all the transactions of machines on the internet, giving you a huge astronomical number, does it make you more happy, or does it do anything? It doesn't. So what I'm saying is the internet, the web doesn't have a TPS as a gauge.
Sure.
And anything you talk about TPS, you're talking about one machine. Even though it could be many machines, physical machines, but you are trying to achieve one task. Somehow one task meaning you interact with one another. You're not completely independent, right? So let's say you get 1,000 machines or 1,000 CPUs. Collectively, you want to do some parallel programming, solving some matrix algorithms.
Yeah.
Then those machines have to interact at certain points. That's a key notion. The other one is to achieve better performance, you want those participating parties to talk to each other less likely. You don't want them to talk to each other all the time, to wasting other parties' time, right?
Sure. Yeah.
But then the first thing is they have to talk. Otherwise, they're irrelevant. The second statement is that you want them to talk to each other as less likely as possible. Correct?
Yeah.
Then Amdahl's law is about a diagram. Here you add more machines in one dimension. You add more CPUs in one dimension. Okay, you got one machine, you got two, you got four, you got you got 8, you got 16, you got 32. It's all binary, right? Just like you just keep adding more machines. Yeah. And then the other dimension is that okay, how often are you going to talk? Every 1,000 instructions, every instruction, you talk to each other, and you're not going anywhere, right? Every statement executed algorithm, you talk to one another. It's extremely slow. Yeah. Then how about every 10 instructions? How about every 1,000 instructions? How about every 10,000 instructions? How about basically multiple of 10, right?
Yeah.
Right. So it's just say eventually, I don't talk to you every billion instructions, every 10 billion, right? Every quadrillion, I'm not going to talk to you. So we're independent until a billion instructions later, we need to think, we need to check each other's result.
Yeah.
Right, and then we swap some data, then we continue on.
Yeah.
Right. So then the curve you're drawing in that two-dimensional diagram is the performance, right? Given given adding more instructions and talking as likely, are you going to get a linear curve? Give you more instructions and talk more likely, you keep on gaining performance.
Yeah.
The result is very, very pessimistic, very extremely depressing.
Yeah.
I was thinking, became a supercomputer architect. I had a dream when I was in college. Yeah. And University of Illinois is known for building supercomputers.
Yeah.
The best school building. That's the very first computer lab in universities all over the world. Very first university computer lab.
It became the National Center of Computing, supercomputing applications, right? So it was.
And also, there's another center called Super CSRD, Center for Supercomputing Development and Research.
Amazing.
And they built the first transistor computer, first parallel computer, first integrated circuit computer. They built quite a few. Then they also built the last parallel computer by university. And after that, no university could ever build any more supercomputers anymore. That's around the late 90s, about early 2000. Then no more university could build, could afford to build a supercomputer anymore. So basically they built the first and last. And the reason why I went there, because I want to be a supercomputer architect.
Yeah.
How depressing. Basically, they have test bench, and to simulate consumer, not scientific computing. The like Drystone, some other, I forgot the names. Basically, to simulate, okay, you run some words, you run some, not at that time, not necessarily words, but then similar, right? The PC kind of apps. Yeah. And so you put this mix of instructions in there. And basically what you get is a so-called U-curve, reverse U-curve. You reach your, one CPU, two CPU, 4, then 8, 16. Basically around 8, you reach the top, and then you're going down. So that's why we have only 6 CPUs on our phones and PCs until today.
Until today,
right? So I knew the result, 86. Then basically completely destroyed my dream to be a supercomputer architect. I say, I give up, I quit. That's literally the cause.
Yeah, that's really tough. I mean, I'm guessing, from your coming from China as well, and having this dream to then, the feeling you must have had when you first entered. What was that feeling like when you entered the room for the first time and saw a supercomputer?
Because the future is so bleak.
Yeah.
Right. Why bother? So. But anyway, I was limited because I was, after all, just a student. I should know better. I was actually very short-sighted, put it one way or the other. But anyway, that's the law is a law.
Quickly. It's fascinating. And that must have been pretty demoralizing to come to that realization. For me, who's not too tech savvy, what actually is a supercomputer?
The supercomputer basically trying to get this as much cranked out, right, for scientific data. Because let's say forecast, if you do weather forecast, you can basically map the globe into grids.
Yeah.
Can you do like a mile? Basically, the grids is a mile or half a mile, a tenth of a mile. The finer the grids, the better you predict the climate, right? The forecast.
Sure.
But then the thing is, then the matrix is much bigger. Then can you do it, right? And so Amdahl's law basically just saying, adding more nodes, adding more machines, more CPUs to do a collective task, you'll reach your peak very quickly. Then the performance will degrade. Adding more will be worse than not adding any.
So then, would Moore's law enable the CPUs to become more powerful over time, but
Correct.
Only up to 8, and then beyond you're just
no. Moore's law meaning every 2 years or so, 18 months to 2 years, 24 months.
Sure.
Your CPU speed will double. Single machine, right?
Amdahl's law would say there's a limit to which all those CPUs can come together when it's.
If you add more CPUs, it's not going to help.
Oh no, what a dilemma.
Right?
Gutting. Yeah.
You add more CPUs, it's not going to help. That's what it is. So then, not only that, as I said, consensus, meaning we want to check balance each other. We're not here for better performance in the first place. That's just the definition.
Yeah.
It's not, that's why I, kind of my interpretation about Satoshi Nakamoto's saying, if you don't get it, you don't believe me, I don't have time to explain.
Yeah.
Because people are so confused.
Yeah.
Always hoping, okay, remember, now I think it's better now, because when we started the project, 2017, a lot of people were trying to say that can Bitcoin achieve better performance? If Bitcoin couldn't, can we do the BCH or BSV? Or can we do, Ethereum or some other people trying to challenge the public main chain, saying it's too slow, right? So then that kind of some white papers I read, or just basically saying, okay, we can do better than Bitcoin. What do you mean better? Let's say Bitcoin has 1 megabytes, ELA has like 8 megabytes.
Yeah.
But then do we brag about, okay, 1 megabytes and 8 megabytes, but can do more entries of transactions. But after all, it's just a limited number. Let's say, okay, Bitcoin is 10 minutes, ELA is 2 minutes. And should we brag, ELA is 40 times faster than Bitcoin? According to, those old way, a way of calculation, first of all, I don't even like the term TPS for blockchains because you cannot commit in a second. Then transaction per second literally means you have to commit. If I'm buying a train ticket, did I get the ticket or not?
Yeah.
You can't just say, okay, I'm not sure. That's not a transaction. The transaction saying you get it or you didn't get it, right?
Yeah.
Within a flip of time. But then given a second, can you do 100,000 transactions, selling 100,000 train tickets? Any blockchain, no blockchain can do any number of train tickets in 1 second, because you cannot, right? You only do average. 30 minutes later, then you go back to say, okay, I commit this block, and this block has 4,000 entry in it.
Yeah.
So that's not a TPS. I mean, better find a new name. And even it said, okay, Bitcoin has 6 seconds on the average, right? After 30 minutes commit. And then you say, okay, average, every second so we can log 6.7 entries. Whether it's 6 or 60 or 600 or 6,000 or 6 million, it doesn't really matter that much. It's just engineering-wise, it's just a number. It's not going to solve internet problems. As I said, are we going to have even 6 million, 60 million? Are we going to sell all the tickets in China, in US, in Europe on the internet with 1 ledger? You can't. Internet consists of many ledgers, many computers, right? You can't expect 1 ledger to solve all problems. Let's say I was looking into like a Lightning Network recently, and then the reason is twofold. One is that not only ELA has to do the ledger, but also let's say we have Hive storage, we have carrier streaming. Are we going to do a ledger for streaming as time goes by with a timeline? Let's say I consumed this much bandwidth, I consume this much movie, consume this much movie contents, right? Files. Should I pay Filecoin? Should I pay Hive? Accordingly, right? If I consume the 6 seconds, I consume the 6 minutes. Should I pay, right? Instead of paying a whole movie.
Yeah.
So that kind of accountancy, we need this kind of a ledger to do it. then the current Bitcoin or ELA way of accountancy is not good enough, or it doesn't fit this kind of streaming needs.
Yeah.
Right, so we have to find a alternative. I'm not saying ELA is not important, but then because of the applications are different, we need a different kinds of consensus ledgers.
Yeah.
So in that regard, the internet needs many different, maybe Algorand, IOTA, some other consensus algorithms, right, to meet the needs of a new web. But you cannot just say, okay, this one is better than the other one, or this one is going to be the only one.
Yeah.
So that's why you see Heiko fork Ethereum because of the congestion, because the fees were too high. I'm not saying the invention of Ethereum is not good, but definitely you'll see the fork on the web. That's why I see we support FUDA. The reason why we support, when some community members ask, why do we support FUDA, and what's the relationship of FUDA to ELA, because it's not running on the ESC sidechain. But that's a kind of, first of all, as I mentioned, the Web3, the smart web, should consist of many different sidechains and friend chains, can be just achieved by one party. If you take that kind of point of view, you see we definitely were welcoming, like a Heiko or Ethereum or other blockchains, or Definity for that matter, to succeed, to be the alternatives. And of course, we have a team like really defend the attacks, right? And people have already observed, of course, there are always intrusion, hackers trying to sabotage the FUDA chain. And then basically they're doing a live ammunition war game. And then we're exercising the team. Then when they come back to support the Elastic chain, let's say for the decentralized exchange, for the stable coin, then we can have more confidence in the code or in the experiences of the execution team.
Certainly, and strategically it makes sense, and having allies is always a good thing. And actually, from the Heco side, I think there's good connections there, and there's good decisions there. It's really interesting, and the Lightning Network, similar here. I've been exploring, and that layer is fascinating. And doing these transactions where you can account for everything, almost like a layer 2, and then batching it all onto the blockchain as one. That's kind of where everything's heading, where it's not all done on chain immediately, but you need to have that speed.
After we talked about Amdahl's law basically is about the foundation layer.
Yeah.
Right, the foundation layer, whether it's 6 transactions on average, or 60,000 transactions on average, that's just by design. What do you want it to do, right? But for the internet, we need many different kinds of consensus and blockchains. Now we're talking about the second tier. And if you see, Ethereum is doing second tier, Bitcoin is doing second tier, and many blockchains are doing second tier.
Yeah.
And here, that's my honest opinion. I'm not shy of telling in public, but on the other hand, take it as a grain of salt. I have very limited knowledge, and I'm just another human being, make mistakes.
Yeah.
My understanding of tier 2 is that tier 2 is a different beast. It's not a blockchain.
Yeah.
So a lot of people say, okay, Lightning Network plus the Bitcoin, that's a Bitcoin stack. Or Ethereum tier 2 with the Ethereum, that's a Ethereum computer with better performance. Basically, the notion is still a ledger, it's still a world computer, right? With layer 1, layer 2, there's still a
under the same
ledger,
block.
still a computer, just say doing faster transactions, and the scalability reach more nodes. I don't quite agree with this kind of notion. I did a comparison, like a battery is a battery. If you put four wheels on the chassis, it's an automobile. It's not called a battery anymore. You can't say a chassis with 4 wheels is a second tier of a battery. That's not right. Because if you see Lightning Network, remember what we also talked about trading chain some time ago, right? Or talk about decentralized banking, like Elephant, ELA Bank, or Elephant being, a node. So what that said was, okay, if my if I send you a Bitcoin, it takes too long, right? I want instant payment. So we can have a multi-signature wallet. And whether it's 2 signatures or 3 signatures, like Lightning Network, you have a signature, I have a signature, but then I put in a predetermined smart contract. So if I have residue found in there, I can always take them back. Or in the trading chain case, they have 3 signatures, one cold wallet, one hot wallet, you have wallet. No, you have signature. I have a hot signature and cold signature. Basically, we modify the chain, right? Saying if I have a pending transaction, my backup signature won't work until the transaction cleared. Then, because after all, the ledger is programmed. Right? You can program such that, if I have a pending transaction, we have a dispute, then we have, let's say, 24 hours to solve our disputes. Otherwise, I couldn't just withdraw funds, right? So similar to a smart contract in a way, like a Lightning.
Yeah.
And what I'm saying is that if the multi-signature wallet has some funds, pre-deposited funds in there, then if I give you instruction saying, hey, hey Sash, could you pay $5 to this Starbucks secondary decentralized bank, right? Let's say one is called ELA Bank, and the other one is called a Starfish Bank. I'll say, okay, since you are the ELA Bank owner, saying, hey, Sash, could you pay the Starfish Bank on my behalf for $5? Because each bank has some staking in this banking sidechain. And you're using centralized Oracle databases. So because you each have a staking, then you just pay $5. Then because given my signature asking you to pay on my behalf, you also have a signature. You have already started the transaction of my fund from my wallet into the pool, right? We were holding this multi-signature pool, basically. I pay you back, but then I won't pay you back until 30 minutes later. But given the 2 I have already signed, and given that ledger won't let me exercise my my cold wallet, my cold wallet signature, or I won't be able to activate my withdraw funds from the smart previously co-signed smart contract. So you have a high confidence I'm going to pay you back.
Yeah.
And then you pay Starfish Bank on behalf of the Starbucks, this Starbucks vendor, right? So in that way, it's a basically centralized old way of doing business, 2 banks doing business. Whether it's a 2 bank like US has 5,000 banks, or Lightning Network has 50,000 decentralized banks.
Yeah.
5,000 versus 50,000. What do you think?
Yeah.
Is that decentralized? Is that centralized? Is that really a blockchain? That's kind of it's a different beast. That's a different financial system. It's not the Bitcoin extension anymore.
Yeah. Yeah. No,
right?
it's really interesting, and again, it raises the question that over time, do we naturally aggregate ourselves towards centralization for efficiency? And I mean,
that kind of centralization is still because decentralization is an ambiguous word. Because first of all, a decentralize a cloud, decentralize a DAO, is that really peer-to-peer? Is that decentralized? It's still a center. It's a loosely controlled center.
Yeah.
Right? Versus pure peer-to-peer. So that's a loosely controlled center. It's not really a decentralized.
Yeah.
And the other one is that as long as I have choices, including I don't believe anyone, I build my own. As long as I have the option, should I always rely on myself? Regardless, right? Sometimes I just happen to trust you, and some other things I happen to trust someone else. Sometimes I happen to don't trust anyone. I build my own Raspberry Pi. Do I have that choice? So multiple centers that I can trust. If we take that stance to build what we want to achieve is the new internet. It's not really arguing academically, academically saying, okay, oh, you're not. What's the point? What are we trying to get?
Yeah.
And the other one is, the reason why I'm saying tier 2 is not the same beast is, if we use Bitcoin, the second tier Lightning, because that's staking, I'm paying you back, right? Because you are the ELA bank, I'm paying you back ELA. But the Starfish Bank, are they using ELA? That's the question, right? Do they have to? I mean, Starbucks, for you, we're using ELA to do clearance. I pay you back ELA.
Yeah.
And okay, in my wallet, shared pool, we have, let's say, $10,000 worth. Then I'm asking you to pay $5 on my behalf. Basically, that's a collateral, correct?
Yeah.
Whether I use my house as a collateral or I use ELA as collateral. But what about Starfish? Are they going to use Ethereum as collateral? Are they using Bitcoin as collateral? Are they using really Euro as collateral? Does it really matter? So why should we say the second tier trading chain being the extension of ELA? You see where I'm trying to get?
Yeah, I think
and
so.
On the other hand, is this a trading chain, the second tier banking system, semi-centralized banking system? As long as we have choice, it's a permissionless. More people can go join into this 50,000 banking alliance. Do they have to belong to the same ledger? The tier 1 ledger.
The Ethereum, yeah, sure.
So is this a Lightning chain extension of Bitcoin? That's my question, right? That's why the tier 2 is a different beast.
It's almost like you're entering a building and then taking the elevator up, and you can't access other buildings because you're up in that building and you've got to operate on those terms. Am I right in some degree that what you're saying, that the reason why that's not great is because you have to make decisions based on that chain and what you're on, opposed to something that's more interoperable? And
the reason why is I'm just saying tier 2 is not really tier 1, extension of tier 1. Because of eventually, ultimately, we're building a new web.
Yeah,
we have to let consumers to have a choice. As I said, the Lightning nodes, currently, of course, they do staking with Bitcoin because it's programmed in, but then can we modify Lightning Network so then ELA can be also be used as a underlying staking coin?
Yeah.
Along with Bitcoin, right?
Yeah.
Then in the channel, now they clear Satoshis between them, but then can they clear euros, the digital euros or digital RMBs? After all, it's a staking and lending.
Yeah.
Right? So lending, I mean, should I lend you BTC or should I lend you Euro? And also for a web, as I said, this kind of accountancy, should we have more different kind of, because the internet needs different kinds of tier twos, right?
Yeah.
And given even that said, all tier two added together is not a web, because web has a lot of singletons, solo nodes, and those nodes, as I said, if we trust just one machine doing the betting on an Olympic game result, is that okay? Or if it happen to be a set-top box or it happen to be a cell phone, I mean, the web is connecting all nodes,
Yeah.
blockchain or not, right? And that's the web. It's not the web consists of only tier twos.
Yeah, sure. They need to all just be connecting to each other, and it's really fascinating. So the question being, what do you think is the future of Bitcoin?
Yeah, Bitcoin, on the other hand, is a super, I believe, because also ELA is doing merge mining with BTC.
Yeah.
Because of, after all, at least until now, right, BTC has the most trust.
Yeah.
Hash rate wise or consensus wise, like some third world countries. And if you ask them, should we, I mean, not necessarily saying Ethereum is not trustworthy, but then how many, there's a big free theory, like a three TV broadcasting channels. And like if you go listed on NASDAQ, every market segment, they have the first, the second, and three, because of human minds can only remember no more than three, right? For a lot of, with normal IQ, I'll ask you, who is the best doing game engines? Who is going to do the search engines? Like Unreal, Unity, only two. Who is the mobile operating system providers? Okay, Android and iOS for Windows and for PC. That's all. I mean, of their Linux. In each market, right? A cell phone has maybe like two. For PC, there's another two. Linux and Windows, and the mobile is Android and iOS, because people don't remember, and also because of the vendors, or they don't have resources to support 4 operating systems.
Yeah.
Or they don't have a bandwidth, right? For a gaming company, they don't have bandwidth to develop for 3 game engines. So for the top 2, Unreal and Unity, maybe I can have a 3, but then after 3, do I want my game to run, more than 3 game engines? You don't. So what I'm saying is the fundamental layer, which one, right? Top 3, like BTC, Ethereum, who's the number 3? People can argue the most trustworthy. But then after 3, and how many people can remember 1,000? Currently, that's how many cryptos there are, right? No one can remember 1,000. For example, ELA 400 some. Who is remember ELA? No one. But then that's not the point. The point is, of course, we hope we can do better than 400 ranking. But what about 40? The crypto rank number 40. Is there a future for the number 40? As a technology, that's okay, because technology, we can do a lot of different inventions. But as a platform, the fundamental trust layer of a whole new internet, no one can remember who's number 40.
Yeah.
So then number 40 is as bleak, the future, as number 400. They're equally bleak. I'm not saying it's good.
Yeah.
Right? But on the other hand, that's not the point. That's not what we're after. The point being, if it's a permissionless get a machine, then you are part of the Bitcoin network. Yeah, I mean, it consumes electricity to do the hash calculations. But then do I need to own Bitcoin so I can be a Bitcoin miner? Arguable. You can do like right, POW or DPoS, POS or DPoS.
Yeah.
But still, we can only have very, very limited number of fundamental main chains for the new web.
Yeah. Yeah, I love the fact that we are the main chain, the Elastos main chain, which is deflationary as well. So it has halvenings like Bitcoin, and it acts as the trust layer to the Elastos ecosystem and the Web3. It's merged mined with Bitcoin. So, I mean, I think that's the future, at least. I agree. I think the number one is Bitcoin. It's king. Its network effect is only growing stronger. It's solving a monetary issue today, which is extremely important, because currently we're grabbing debt from the future or money from the future on the promise to pay it back exponentially in bigger numbers, and we're almost gobbling up everything in our paths because we have all this money from the future that we're never ever going to be able to pay back. So Bitcoin introduces this deflationary mechanism which you can trust and you can hold as a store of value. And then for miners, there's this whole game theory in place where they're incentivized through Moore's law every 2 years to get the latest mining rig, or me as someone who's not mining to get the latest mining rig and have a slight advantage over the person 2 years ago to help protect the system, and in doing so earn more Bitcoin. So I think it's just going to continuously grow and get bigger and bigger. And in doing so, it's the ones who attach themselves to that security and that hash power, which is what Elastos does. So today we have just over 50% of Bitcoin's hash power, which is 54.5 EHS. I'm just looking at that now on elanodes.com.
Yeah, and also because after all, we are after the Web3, and I repeat myself, right? Because we want to give consumers a choice. We're not saying we're the only one, but on the other hand, we don't really have to bet on BTC. Currently, we definitely rely on BTC. Let's say in the future, it's not BTC, the quantum computer is coming up. Let's say, this BTC ledger is not quantum proof. But then definitely there are people working on those quantum resistant, right, or ledger, because this is a new way of thinking. Before Satoshi, there was no consensus computing. Whether the consensus computing is achieved by hash or it's by like Ethereum kind of ledger, right? UTXO versus a different kind, or versus quantum resist kind of ledger. At that time, we realized this consensus computing smart contracts are going to stay with us. So then it gives us a foundation to issue IDs that based on IDs and crypto keys, and whether it's a quantum resist, right? Then so then we own our own data. We can encrypt the data, put it on a Google Drive. Then we can share, right, peer to peer. Those are the things which before 2009 or 2019, to be specific, was inconceivable. Yeah. Now those ideas will live on. That's the key point we're trying to get, right? If it's not Bitcoin, there's a quantum, so what? Then we will just need some porting and port the new upper layer onto the new infrastructure. Then that's it.
Yes, there's agility in where you pick and choose, but certainly today in the current current world, this is the right choice for security. And holding ELA for me on the ELA main chain is a very secure environment, to be honest. We talked about Hecko, for instance, creating an Ethereum smart contract fork, but what they sacrificed was security, in that they've centralized their nodes to allow for efficiency and speed. Now, that's, in theory, that could be attacked or could go down one day, as any network has the potential to be. But knowing that you have, Bitcoin security, and on the ELA main chain, an attacker has to take out both the super nodes. So just to be clear, it's a hybrid consensus mechanism. So you've got the proof of work, which is the Bitcoin miners who create the blocks, and then you've got the super nodes on the Elastos side, on the Web3, who package those and put it onto a blockchain. So in a way, you've actually decentralized the consensus mechanism, where you have to take out both parties in order to take down the network, and that network helps support the whole ecosystem of Web3, of the Elastos Web3. And it's a great place to be as far as storing your assets. But we can pick and choose as you want. But it's interesting. I mean, I'm guessing you came across blockchain through Bitcoin, and it must have inspired you along the way, Rong, to your vision today and what's possible. So it's good just to hear your opinion on what you think about it and where it's going. Okay, so I think we're pushing on time. I still have questions. I mean, we could go on for ages, Rong. I do love these conversations. I'm going to throw a big one at you. What is the single most important thing, in your view, that must be done in order to make the internet evolve?
Well, of course, I have my limitations, because I'm from the operating system background. I would consider the new web, the network OS, would be the single most important things that's missing on the current internet. We need to have a network OS, and also this network OS is kind of open, more open than Linux. As I said, it's more like Linux is still a single machine OS, because you can upgrade version 1, version 2 at the same time. But given the name Elastos, I also mentioned in my Twitter, it's two things. One is everlasting, because of the internet cannot have a version upgrade. You cannot say, okay, my node upgraded and some other nodes not upgraded. No one can force the all nodes to upgrade at the same time. And let's say we have this ID, and are we going to prevent new IDs from like different parties to supply IDs, right? If we have Hive nodes, are we going to prevent other nodes from providing storage, right? We're doing carrier to do logistics and messages and video streaming. Are we going to prevent other parties from doing the same thing on this new web? So as long as people can come together, like W3C consortium, then decide or agree on, let's say, consensus protocols, streaming protocols, and storage protocols, then we can collectively build this web. But collectively, this web, if you look at operating system in a broad sense, right? We need to quarantine apps. We need to give individuals a silo to store their own data, and we need to empower individuals to stream to million audiences conceptually peer-to-peer. But of course, a lot of miners, those decentralized centers, to help them along the way getting rewards. So that's another comment I want to make is, what's the ELA, right? Are we competing with Bitcoin? Are we competing with, are we security? Are we utility? Are we tokens, right? If you see field up, like liquidity mining, because we need to reward whoever help us provide storage, We need to reward whoever provide the streaming relays, right? We need to provide DeFi, those fiat lending, borrowing, staking. Are we the only one? No. But are we currently, I believe, have this kind of unique vision, trying to be the open-minded ones in there? Right? So those are the questions I'll give to our communities. And we can use BTC, like Lightning Chain, for those matters, right? Are we going to reward BTCs to our storage miners? Because of BTC doesn't, BTC only rewarded the BTC miners. There's no extra to reward storage miners or streaming miners, or DeFi liquidity miners. So we need a new token for that. And also, we are definitely in the process of, because Elastos controls only BTC. Elastos, I wouldn't say I have no ELA, but Elastos has very, very limited number of ELAs, right? So Elastos Foundation is not doesn't have a direct using ELA as voting power in any way to influence the ELA community. So that's our understanding. We definitely welcome like Microsoft, other folks to help with the Web3, and they can issue their own liquidity mining, utility mining tokens. So then ELA is competing with those liquidity or utility tokens, correct? We just hope being the first mover and being more open-minded because of, and also being small. Because if, let's say, Microsoft's going to do it or Google is going to do it, it's not that they could. First of all, the bigger the corporation, the more bureaucracy, regardless. Right? I was with Microsoft, I was with Foxconn, so I know. And basically, the bigger organization, they have their own different kinds of worms to worry about. And also, if it's a big corporation, let's see, there's also geopolitics involved, because is that bigger name will influence right different regions to cause distrust or trust. So at this point, I see the web has to be open sourced, and that Linux was open sourced. But the problem with the Linux Foundation was that, or the old internet was that no rewards for the participants. So then they don't, basically what I'm saying, going back to the governance model, the governance actually, by and large, government is collecting tax. The startups are making profits. So these are completely two different beasts. The platform is collecting tax, and the startups are making profits. So utility actually is also helping to build a sub. I mean, let's say Web3 is a metaverse. We are building a cyber republic, a sub community on this new new web, right? In the new metaverse. But then this new sub community, we need some way to reward the infrastructure builders, and also we need the reward the influencers, whoever contributed the contents, getting the admins, getting different groups, organized side chains, the cultures, the religions, different geopolitical regions. So we need admins for all of them to reward them. And so in a way, the transaction fees. someone has to collect transaction fees, because like current internet, we're paying for, let's say, sign up for ISVs, the bandwidth. We're paying this telco companies for being able to access the internet. It's not that internet is free. Everyone's paid for the telco companies to get online, like pay the bandwidth on your 4G, 5G phones.
Yeah.
Right. But the thing is, those telco companies and the internet companies and that those content platforms, like Google, Yahoo, Facebooks, right? Those content platforms, they're not really, the tax is not collected as a whole, right? It's not, because let's say to avoid Apple take 30% of the proceeds to play the big brother role.
Yeah.
Or like Tencent, gaming platform, Tencent takes 80, right? To maintain the gaming platforms. The content, actually the WeChat, they don't make money, but then by getting more users to play their games, their gaming platforms, they can have a premium of 80% of the premium.
Yeah.
And then if we're saying collectively, we're going to make a platform so then the small vendors, game vendors could be on the equal footing with the big brothers. And are we going to reward the whole infrastructure providers, right? Like if you read Microsoft News, like Windows 11, then they start to market themselves as a platform of platforms, because of Windows 11 will support Android, Linux, Win32, which is the old Windows, and UWP, which is the new Windows C# runtime. So they're going to support a full platform to start with. Then let's say if I know Apple has a lot of IPs or a lot of those secrecy in there, but in theory, right? And what's stopping those internet platform to run anybody's ecosystem? So that's where the platform of platforms, the term comes from.
Okay.
Then, and also what I'm saying is, if from you have to pay the telcos, then no one is paying the internet, and no one is paying the Linux virtual machines, right? But Linux virtual machine, Elasus virtual machine, WebAssembly, are they part of the platform providing mechanisms?
Sure.
Should they be rewarded? Can we collect tax, the gas fees as a whole? And can we have, let's see, a consensus saying, okay, whatever, because you have to have freebies. But then whoever's trying like a search, most people are searching contents for free, but then they also Google sell keywords. If you sell cell phones, if you want to be ranked #1 in Amazon e-commerce website, you have to pay.
Yeah.
And should those vendors subsidize the freebies? Then who is collecting? So those are the decentralized governance. Which government, which community has a better policy to attract those e-commerce or game vendors as a collectively, right? Not WeChat gaming platform, not the Alibaba e-commerce platform, but can we build those sub platform for e-commerce, somebody, but which is controlled by decentralization, so it's more efficient, it's less costly, and more fair? Those are the new challenges down the road for Web3. But definitely we can having those sub DAOs or like sub CRCs to decide their own fees and gas premiums, so they can compete with each other.
Yeah.
And that's what I see the future of Web3, because of if you have a small enough sub community, are you going to issue your own token like Filter or WeFilm Chain token? You could, like WeFilm Chain, you could issue your own utility tokens to open a mom and pop shop, right?
Yeah.
But on the other hand, are you going to be listed on NASDAQ, on the exchange?
Sure.
Because your liquidity, you're too small. So you may have to exchange to a more fundamental platform token.
Yeah.
So in a way, ELA is, right, we can say that it's a separate republic. When someone is doing, using a different token to issue a different kind of, whether you call it a republic, union, united, somewhat, something, right?
Yeah.
Or British Empire, it doesn't matter, right? As long as, people like to move there to be competitive, then you can use your own tokens. And but then what I'm saying is, at least when you are in the separate republic community, those WeFilm chains filters on our side chain will be easier to convert to ELA, so then they have a value instead of listed, mom and pop shop to be listed by themselves.
Yeah.
So that's where the value of ELA I see.
Yeah, no, I'd agree. And obviously, ELA is the gas fees for everything on the network. So with a horizontally scalable architecture, you could have all these side chains built, and you can have all these different kind of councils and different governments, DAOs, decentralized autonomous organization DAOs, but they're all as well having to use ELA as gas. So there's utility there in the governance and in the actual tax of payments. Brilliant, Rong. Well, I think that probably about concludes everything. I mean, the weather looks fantastic your side. I think it's earlier your side than mine, but please go and enjoy your day. And thank you so much for taking the time to talk to me. I really appreciate it. And there's always so many good takeaways that I get from these conversations. So thank you, Rong.
Yeah, thanks for having me. Thank you.